So hello dear student, welcome to today's discussion. Uh, in today's discussion we will start with the new chapter of physical chemistry, that is colligative property. As colligative property is very important from the competitive point of view, as there were two questions in the Gpat 2022, as well as there will be probability that in the upcoming Gpat exam they will ask the question from the colligative property chapter. So you don't have to skip this chapter. Always be have a positive mindset that you always have to be in a learning phase, that don't skip any a little bit topic, as every topic have their own importance, and you can do you have your own mindset and you can do anything that you want. So please don't skip any chapter, any topic, whatever you have in your. So today we will start with colligative property chapter. So first of all the question arises like, what are colligative property? So colligative property are basically the property which depend only on the number of solute particles. Colligative property are those property that depend on the number of solute particle or number of solute particle, but it doesn't depend on the nature of the solute particle. How the solute particle are, like what are about their oxidation state, what are about the reduction state, how is the oxidation reaction, how is the reduction reaction. So it doesn't depend on the nature of the solute particles. Like if the solute particle is in oxidation state, if the solute particle is solid liquid, it doesn't depend on the nature of the solute particle, but it totally depend on the nature of solute particle, which type of solute particle is it. So all colligative property are inversely depend on the molar mass of solute. So as molar mass of solute, all colligative properties are depending on the molar mass, and as the number of moles, I hope you all know about the number of moles. Like number of moles are our gram of solute. Like suppose if you have given that 98 gram of H2SO4, and you have to calculate the number of moles of 98 gram of H2SO4. So as you know that H2SO4 is having the gram, that is 98 gram, that is your given weight of solute, that is H2SO4, and the molecular mass of H2SO4 is your 98. So the number of moles of H2SO4 of 98 gram H2SO4 is 98 by 98, means 1 moles. So it depends on the number of solute particle, and you don't have to be skip, like you have to be read about the molality concept, formality, normality concept, as normality is equal to molarity into n factor. So coming to the topic of today's discussion, or we will further move to today's discussion, that is, what are the types of colligative property? So basically these are 4 types of colligative property. As we had when I was in my 11th and 12th class, we were having phobia that how we can read the colligative property. Same the history repeat, that colligative property we have to read it for the Gpat exam as well. So please don't take any type of phobia with any topic, like this is a physical chemistry chapter, or we can say topic that is not in your Pharm syllabus, but it is in your Gpat and NTA, as well as other pharma competitive exam like drug inspector and pharmacist. So first colligative property is your relative lowering in vapor pressure. Second is elevation in boiling point. Next is depression in freezing point, and last is our osmotic pressure. So in today's session we will discuss these 4 properties one by one. First is relative lowering in vapor pressure. Relative lowering in vapor pressure. Why there is a lowering in vapor pressure? By the vapor pressure, suppose we have a solute or we have a solvent whose vapor pressure, like as the name indicates, there is a lowering in vapor pressure. Lowering in vapor pressure means, like, why the lowering in vapor pressure? Same is like you just you are doing your daily revision, you are doing your daily practice, you just lower down, you just get depressed. Why you get depressed? Just because someone can interfering in your life, someone can someone can detach you from your studies. So same is like that, there is a lowering in vapor pressure. So why lowering in vapor pressure, or why it is occur? Because when a non-volatile solute that is added to a solvent, the vapor pressure is decreased, because we are adding non-volatile solute. Non-volatile solute are those solutes that cannot be volatile, or we can say that cannot be evaporate in from a solution. So relative lowering in vapor pressure of a solution containing a non-volatile solute is equal to the mole fraction of the solute in that of solution. So relative lowering in vapor pressure, that is equal to non-volatile, that is equal to non-volatile solute is equal to mole fraction of solute in that of solution. So as this is your relative in lowering in vapor pressure, P naught is our initial pressure and PS is the pressure after the addition of non-volatile solute. So we can say mole fraction is equal to, like suppose we have a solution and containing A plus B, that is solute as well as solvent, and we have to calculate the number of moles of A. So number of moles of A as the given weight of A as well divided by molecular weight. Same is like the mole of B is equal to number of you can say gram of weight of gram of B divided by its molecular weight. So mole fraction of A, suppose mole fraction of A is equal to mole fraction of A divided by mole of A divided by mole of A plus mole of B. Mole of A and mole of B is our like one is solute and one is solvent in the solution, or we can say those whose mole fraction we have to calculate, we can take it up and divide by, we can divide it by the total number of moles that is present in our solution. So this is the formula of relative lowering relative lowering in the vapor pressure. But relative lowering in vapor pressure means the pressure before addition of non-solute particles and the pressure after addition of non-solute particle are different. There means the relative pressure, suppose before the pressure is our 25 atm vapor pressure, and after addition the pressure become 10 atm. So the difference in the temperature, or we can say how relative, I suppose like you have scored 400 marks in your exam, and in compare your friend, like your friend can score 200 marks. So in relative of you, your friend marks is 200 less. So same is like how it will be relative. So we have two methods by which we can calculate the relative lowering in vapor pressure. One is our barometric method and next is our 𝘂𝙂𝙎𝑃𝑒𝑟 method. As in Gpat 2022, they were asking like which of the following is the method of measurement of relative lowering in vapor pressure, and you are able to see the one of the among the option like barometric method, 𝘂𝙂𝙎𝑃𝑒𝑟 method, and both A and B. So you have to correct the option that is both A and B, means barometric method and your 𝘂𝙂𝙎𝑃𝑒𝑟 method, both method are used by your both method is used to calculate the relative lowering in vapor pressure. Next is our elevation in boiling point. Next is our elevation in boiling point. Elevation in boiling point it occur due to addition of non-volatile solute in a pure solvent. Non-volatile solute, same is like we are doing in the relative lowering in vapor pressure. Here we also adding non-volatile solute. In what? In pure solvent. As the vapor pressure of the solvent get decreased, as there is a decrease in the vapor pressure. Why there is a decrease in vapor pressure? Because the vapor pressure of the solvent get decreased, as we had discussed. Due to the decrease in vapor pressure, the boiling point of the required temperature will be higher. Suppose that before addition of the non-volatile solute, our solvent is boiled at 90 degrees Celsius, but we are adding non-volatile solute. When we had added the non-volatile solute, so after that the vapor pressure of that solvent get decreased, that leads to the rise in we can say that leads to the increase in the boiling point, and that increase in boiling point is termed as elevation in boiling point. Got it? So there will be rise in boiling point of the solution. There will be rise in the boiling point of the solution. The increase in boiling point is known as elevation in boiling point. So the pressure, also the temperature, or we can say the temperature, the boiling point that can increase by the addition of non-volatile solute in that of solvent is known as elevation in boiling point. So I hope you are also clear with this property, that is elevation in boiling point. Please reply in the comment box that it is clear to you or not, or I have to repeat it again. Had you clear with the colligative property, that is elevation in boiling point and relative lowering in vapor pressure, so that we can further move. That is represented by the sign, that is TB. TB is our temperature, or we can say the boiling point that can be elevated. Kb is our 𝙂𝙎𝙎𝙎𝙬𝙎 constant, and m is here molality. So m is here is molality, and molality m, that is represented by W2 by M2 divided by W1. So W2, that is the weight of solvent, M2, that is molecular mass of solvent, W1, that is weight of solute. So this is our molality, and Kb here, that Kb is here is 𝙂𝙎𝙎𝙎𝙬𝙎 constant, or we can say molar elevation constant. As there was question in the previous Gpat, and they was asking that what the Kb stand for in the your elevation in boiling point. So you just have to be tick on the option where you have seen that Kb is 𝙂𝙎𝙎𝙎𝙬𝙎 constant, and they will also ask like what is the unit of 𝙂𝙎𝙎𝙎 constant. So 𝙂𝙎𝙎𝙎 constant is having the unit that is Kelvin kg mole minus. So this is the unit of 𝙂𝙎𝙎𝙎 constant, that is Kelvin kg mole minus, and the 𝙂𝙎𝙎𝙎 constant, or we can say molar elevation constant of water, is your 0.52 Kelvin kg mole minus, and Kb, that is your we can say I have a relationship, or we can say it doesn't mean I have, means the 𝙂𝙎𝙎𝙎 constant is having the inverse relationship to the enthalpy of vaporization. So Kb, that is represented by RT. Tb is here Tb is here elevation in boiling point, divided by M2, that is your molality, and HMB. We can say delta Hm is your molar heat of vaporization. Kb is your 𝙂𝙎𝙎𝙎 constant, and 𝙂𝙎𝙎𝙎 constant is inversely proportional to the enthalpy of vaporization, and Kb is equal to 0.52 Kelvin kg mole minus. Got it? So as there were method for the treatment of relative lowering in vapor pressure. Same is for the elevation in boiling point. For the elevation in boiling point, we have method like Lensager method, Beckman method, and control method. So these are the three methods that we are using for the elevation in boiling point, as the barometric method and Oswald method is used for the relative lowering in vapor pressure, and these three method is for elevation in boiling point. So please do confirm that the two colligative property is clear to you or not, or I have to repeat it again so that I can repeat, or you have any doubt in any type of colligative property, please write in the comment box so that I can clear your doubt. Please reply as soon as you can. So I hope all are clear with all topic are clear with you. So next we will discuss about the next colligative property, that is depression in freezing point. As this can indicate depression in freezing point, so depression means like decrease. As depression is a CNS disorder on in which the person can be mentally get disturbed, or we can say the activities of that particular person is get decreased due to the fluctuation in the neurotransmitter, that is known adrenaline and serotonin. So that's why we have to take antidepressant drug like tricyclic antidepressant, typical antidepressant, atypical antidepressant. So next, depression in freezing point, why the freezing point get decreased, why the solvent, due to which its vapor pressure get decreased, and due to which the vapor pressure get decreased, now it would be equal to that of solid solvent at lower temperature. Now it would be equal to the solid solvent at lower temperature. So depression in freezing point, we can say that freezing point of solvent and that of freezing point of solution. Why I had write here solution? Because we are adding non-volatile solid, or we can say solvent. Before that, the solvent, that is a pure form, and if we are adding two components into each other, then it can form a solution. Either the solution is of homogeneous, or we can say heterogeneous. So freezing point of solution, that is somehow solution means like we are adding non-volatile solute in that of solvent. So delta TF, that is the depression in freezing point, is equal to Kf and M. M is here is your molality. And Kf, that is TF, that is equal to Kf. M is molality, as I had explained in the elevation in boiling point. W2 by M2 by W1. So Kf, that is having the value for the water, that is 1.86. This is very important. You have to be clear about the concept of your water, that what is about their triple point of water, what are the critical parameter of the water, what is the freezing point of water, boiling point of water in Kelvin, in Celsius, all the data, like what is the refractive index of water, what is the refractive index of air, how is our dipole moment. So what about the dielectric constant of the water? So you all have to be clear with our water, that is your universal solvent. Got it? So Kf of water, or we can say our Kf is our cryoscopic constant, or we can say molar depression constant, that is equal to 1.86 Kelvin Kg mole minus. Got it? So as there is a decrease in the freezing point, because we are adding non-volatile solid in that of solvent, that's why their vapor pressure get decreased. So the vapor pressure get decreased, that can leads to the lowering in the freezing point. That is called depression in freezing point, and it is having also the relationship between with the enthalpy of fusion, and it is also having the inverse relationship like our elevation in boiling point. We have inverse relationship with the heat of vaporization, as Kf is having the unit, that is Kelvin Kg mole minus. Got it? So there is two method for the depression in freezing point. One is your Rost-Kaempfer method, and next is your Beckmann method. Rost-Kaempfer method and Beckmann method is used for the depression in freezing point, or we can say we can calculate the depression in freezing point by using Rost-Kaempfer method and Beckmann method. These two methods are of this colligative property. As previously the Beckmann method, as previously the barometric method is for your elevation in boiling, relative lowering in vapor pressure, as well as Ostwald method is also there. So next is your last colligative property, that is osmotic pressure. Osmotic pressure, as the name indicate osmotic, so before that the term arise like what is osmotic. In osmotic you are able to see the term, that is osmosis. So osmosis is the phenomena of spontaneous flow of solvent molecules through a semi-permeable membrane from a pure solvent to the solution, or from a dilute solution to the concentrated solution. I can repeat it again, like suppose we have this semi-permeable membrane, and this side there is water. So there is water, and this side we have water plus salt. We can say NaCl. NaCl plus water. So osmosis, that is the spontaneous phenomena or spontaneous flow of solvent through semi-permeable membrane. This is your semi-permeable membrane. From the concentrated, we can say from the dilute solution to the concentrated solution. As there is no concentration, means this is the dilute side, because water, that is very diluted form, and there in this side there is concentrated form, means there is addition of salt into the water, so it becomes concentrated as compared to our normal water. So the movement of solute particle or movement of solvent from its diluted solution to the concentrated solution is known as osmotic pressure. Next is the minimum pressure or the minimum external pressure applied on the solution to make its vapor pressure equal to that of solvent is known as osmotic pressure. So minimum external pressure are those pressures like that we are applying that are applied by external source, not internal, like not of this semi-permeable membrane. We are applying it by like suction, we are applying it by motor, whatever the instrument or whatever the procedure we are following to increase the apply the external pressure, or we can say to make its vapor pressure equal to that of solvent is known as osmotic pressure. So that is our colligative property, osmotic pressure. So for a diluted solution, like there is a theory that for the diluted solution, osmotic pressure is proportional to the molarity of solution at a given temperature. But for the concentrated solution, it can become changed, or we can say osmotic pressure method is a best method of determining the molecular mass of the polymer. This is very important question from your pharma competitive exam, as one time this question was asked in the pharmacist drug inspector exam, and one time or two time I think in the NIPER and Gpat exam, and they was asking like which of the following property is the best colligative property for the determination of molecular mass of the polymer. This is the same line that were come in the all the previous exam, or there will be probability that they will ask that about the best colligative property, that is osmotic pressure, that is used for the molecular mass of that of polymer. Got it? So molecular osmotic pressure, that is equal to pi V is equal to nRT, and pi is equal to W1 pi V is equal to nRT, and what we are doing, pi is equal to nRT by m by V, or we are writing n is our number of moles, we are writing it as W1, that is weight of the solute, by molecular weight, V is the volume, RT, or this term become C. So pi is equal to CRT, or we can say relative pressure, or we can say relative pressure between the osmotic pressure as well as vapor pressure lowering at infinite dilution is having the relationship like pi is equal to RT V1 log P naught by P. So this is very important relationship. So same is like for this colligative property, as we had discussed about the last three properties like relative lowering in vapor pressure, elevation in boiling point, depression in freezing point. These are the 5 methods that we are using for the osmotic pressure determination, like how the osmotic pressure of the solvent gets changed on addition of non-volatile solute, or in external applied pressure, minimum external applied pressure. So the method, that is 𝘖𝙀𝙀 method first, next is Morse-Fraser method, next is Rice plasmatic method, Pfeffer method, and Townsend method. Townsend method, or we can say negative pressure method. So these are the 5 methods you are able to see. The question will be like that, like they will ask like, but which of the following is the method of determination of colligative property, that is osmotic pressure, and you are able to see the option 1 or 2 among these method, or 1 or 2 among from your previous colligative property method. Got it? So please don't be confused during attempting the questions. So we had done with the colligative property chapter. So I hope you had enjoyed this lecture. Please follow our subscribe our YouTube channel, like our video, write a good comment if you like our way of teaching as well as our content. Follow us on Instagram, and we had started the rapid revision course as well as we are launching the app. And have a good day. Always be in a positive mindset, because like we have a mindset like our expectation are more, like expectations means like we are expecting like that we have to do hard work. I want a good rank, I want this type of things, I want good result, I want this book, I want that things, I want that food, I want that clothes. Because our expectation and our wants are more and we are doing less hard work. So you have to be a balance between your expectation and your hard work. Because somehow like if your expectation get down, get down, it doesn't happen, but your hard work get down and your expectation become high, that leads to your this colligative property, that is depression. So why the today's young generation are under the depression? Because their expectation is high. They are expecting that I want this, I want a good rank, I want good college, I want good salary, I want this type of food, I want that type of clothes. But the hard work, or we can say hard work and the good work, or we can say honesty from that want or for that things is down. Somehow we are not taking so much serious. Like we are thinking like I want to become a big man, I want to get a package of 10 lakh, I want to get a 2 lakh salary per month. Our expectation more, but our hard work, smart work, helping nature is down. That's why expectation high, hard work come, that leads to depression. That is your depression in freezing point property. Not freezing point means only depression. So always be have a balance in between your resources as well as your expectation. In your expectation you have to be balanced with your resources. The resources you have, be try to be do best from your resources, as all have their limited resources. I have also my limited resources. All the other students also have their limited resources. Be happy in your resources. Don't be like that he or she have some type of other things and I have other things. He is totally different, that's why he has his different things. You have totally different, so that's why you have different resources. But utilize your resources or in a best value. So thank you, have a good day, be happy, keep learning.